All right, welcome to our fourth video of our fifth unit of AP Chem. This one talking about enthalpies of reactions, basically enthalpy part 2. So the enthalpy change that accompanies a chemical reaction is called, well, the enthalpy of reaction. We typically denote that by delta H of reaction. Rxn is basically the abbreviation of reaction. Don't use that on your English class, but it will work in chemistry. So whenever we provide such a value, just saying, you also need to show the reaction it's associated with. You're going to learn very quickly that if you have A producing B, and you also have B producing A, like you basically show me the same reaction, just reversed, the enthalpy of this reaction, the second one, is going to be the negative value of the other one. So if one way produces 10 joules of energy, the other way is going to absorb 10 joules of energy. It's quite important to actually tell me what reaction, because that really will determine what our actual enthalpy change will be. So in general, a reaction proceeds from reactants to products. And so any energy chain occurs by or from reactants turning into products, whether bonds are broken or released, etc. So the change, our enthalpy of reaction, is typically determined by combining the enthalpy of the products and subtracting the enthalpy of the reactants. Now, unfortunately, we're not quite doing that in this section yet. We'll get there. But that typically is defined as basically products minus reactants. We've done this before, but let me point out something. There's no delta H here, and there's no delta H here. That means you're not finding the change in products or the change of reactants. You're just finding ultimately what is the total enthalpy. It'll actually come from the enthalpy of formation of these products. What about these reactants? So you'll actually figure out how much energy would it cost to form these, how much would it cost to form these, subtract out the difference. So we'll get there later though. However, before we even get to that point, there's 3 pieces of information you got to understand about enthalpy. Number 1, enthalpy is extensive. This is opposite of intensive, but extensive means that the enthalpy change is dependent on the amount of the substance involved. That means that a smaller substance will have a smaller enthalpy change than a larger substance if they both experience the same temperature change. So you've got a little bit of water, and you got a big thing of water. If you're going to have to get both of those actually boiling, you're going to need a lot more heat for this one than the small one. That means that enthalpy is dependent on the amount of the substance involved. They don't just take the same energy to get to the same temperature. Number 2, the reverse enthalpy is negative. So the energy transferred into a system is the same quantity as that transferred out of the surroundings. So if you reverse a reaction, it's the same amount of energy. It just may be coming into the system or as opposed to out, or out as opposed to in. And the enthalpy change of the reverse reaction, mathematically, is the same in quantity, but negative in sign. So if this way was 10 kilojoules, this way is negative 10 kilojoules. That's just kind of what we're talking about. Number 3, enthalpy depends on states. That means that different states have different amounts of average kinetic energy. We've talked about this before. And our enthalpy change is depending on what states the reactants or products are in. All right, so let me give you a diagram. You got solid, and that was weird. You got solid, liquid, gas. For those thinking, should we write this down? Yes. Energy increases this way. That means that gases have more energy than liquids, which have more energy than solids. Okay? That's basically what this, in general, means. So, that'll help. All right. Let's do an example. This is a little bit different, again, from those products minus reactants, but it still comes down to enthalpy. So we're saying we combust ethanol, and they tell us our formula, weight, which again is our molar mass. And here's the equation. Notice they showed us And they even showed us that our enthalpy change. Since that's negative, that's exothermic, which should make sense if we're combusting it. That implies fire. They're saying, what's the enthalpy change for combustion of 15 grams of ethanol? So this reaction says that if I have 1 mole of ethanol, 3 moles of oxygen, I get 2 moles of carbon dioxide and 3 moles of water. This is implying that I have negative 555 kilojoules of change for every 1 mole of this, or for every 3 of this, or for every 2 of this, or for every 3 of this. However, we have 15 grams. Step 1, grams to moles. Step 2, moles to kilojoules. So we have 15.0 grams of ethanol. We're going to moles of ethanol. And they told us the formula weight is 46.0 grams. How nice of them. And then finally, 2 kilojoules, negative 5555 kilojoules over 1 mole. Now, before I go on, let me tell you something. The question says, what is the enthalpy change? That means I need to keep this negative. However, sometimes they will say questions like, how much energy is released? In this case, you'll notice it's exothermic. So they're saying, all right, I know it's exothermic, but how much am I going to get when I combust 15 grams? So in that case, you don't need the negative. So if they're just asking about the change, you keep the negative or the positive. If they're asking specifically how much was released or increased or absorbed, don't worry about the negative. This is just like back to the rate of appearance versus the rate. If I say rate of appearance, it has to be positive, or if I say rate of disappearance, it has to be positive. If I just say the rate, it can be negative. Or if I say, how much did you grow, you're going to tell me a positive number. Versus, what was your height change in the past few years? You can then tell me negative, which implies you shrunk. So keep in mind what they're wording. Normally not that big a deal. Anyways, when you multiply these together, you get negative 181 kilojoules. Again, I kept that with sig figs. I don't know if I said that before, but I kept that with sig figs because we did start with 3 here and 3 here, and all we did was multiply and divide. You don't have to. You could have put 180.98 if you want, but it's pretty much negative 181. And again, that negative is because they're asking what the change was. If they had said how much was released, it would have been positive 181. However, that's our enthalpy video. Thanks for watching. Have a good day.